Hi, I'm doing Paul McWhorter's Pico W lessons, and we're up to lesson number 73, and it was playing around with colours and using a colour dictionary to light up an RGB LED and things like that. Now I'm doing mine slightly differently. I'm using the my solution to lesson number 12, which is about over a year ago, to control everything, and so I've saved just my colour dictionary into that file. I would tend to use a JSON file for it, because then it's easier to, if you are adding colours to your dictionary, you can just save it when you go Control C, but that is by the by. And then I've also got my an RGB LED library file to control that, so that looks quite long, so I will just show you what happens. I've got two RGB LEDs. Now that one is a common cathode, and that one is a dreaded common anode, and having two RGB LEDs with PWM and things like that, you can get clashes on the PWM pin, so I thought that if I was using 5, 6 and 13, then I could use 19, 20 and 21, but no, the blue kept tripping it up when I was doing it. So when I was running the program, the other LED was coming on. I thought that was very odd. Anyway, we will just demonstrate this. It says colour required. Oh, I am connected to the left hand one. Red. Yep, it's red. Orange. Yep. Pink. Pink is invalid. Do I want to add it to the dictionary? Yes, but I have no idea what pink would be, so we will go yes, add, and then if I make it 180, oh, let's try 20 and 20. What would that do? Blimey, that actually is pink. Enter a colour required, so I'll go question mark, and there you can see in my dictionary I have pink, which is why it would be really good to read in your dictionary as a JSON file and save it as a JSON file, because then you can save pink. Is that about it? Oh, if I put in something ridiculous, is it invalid? It's invalid. Do I want to add it? No, it just turns it off. So that's how it runs. Now I can use the same program, I hope, Control C. If I change the RGB to the LED to the other one, see what happens. Enter colour required. Yeah, it works, even though you have to, on a common anode LED, you have to set it high to be off and low to be on, if you get my drift. But when I was testing this out, when I was turning red off, blue came on because of the clash. So that is about all I need to do for that. Now, my RGB LED library, I've put in loads of stuff here, and the best way really to show what it does is to run it in a shell. But a quick breakdown. So this is a class. I've got def dunder string, which if you go print whatever your object is, it will tell you what pins you're connected to. Then that is just setting the values of the LED. And then what I like is I've made all of everything start with underscore, which means it's a warning to people not to mess with them. And then here you can get the properties. So if, say, you want color, you can just go RGB dot color and it will tell you what color it is. And if you, I only found this out recently, but if you've got an at property, underneath you can have an at setter for it, and you can set it, which is how when you're using some libraries you can just go color and it will give you the color, or you can go color equals and it will change the color, if you get what I mean. It's like, and I've got pins and everything like that. And I've got blink. Blink doesn't work. My head was hurting, so I gave up on blink because it's quite difficult. If it's just on and off, it's one thing, but if you're changing colours, and I thought I'd leave that. So what I will do is I will open up Shell and I'll snadge some snadge is not a word. I will nudge some lines from here. So I will copy those two and put it in Shell, and then we will start off with the normal. Nothing's happening. So if we go down here, we can see, no, if we go down to the right into my library, we'll see all the things that we can try out. Right, so I will try print RGB. Yep, connected to 5, 6 and 13. What else can we try? RGB dot color. Yep, tells you the color. Then you can go RGB dot color equals 255 dot 0.255, and it's gone magenta. It doesn't look very magenta to you, but it looks, oh look, lovely magenta. Then I can go RGB dot red, and it tells me that red is on 255. Then I can go RGB dot red equals 0, turns it off, therefore it's blue. I can go RGB dot green, which is off. I can go RGB dot green equals 255. You can play around with this like anything. Right, so you can go RGB dot common cathode, and it tells you it's true, which, as I'm using that one, I set it up as the common cathode. I won't bother with the getting the duty factor and everything. You can see what the frequency is, RGB dot frequency. Yep. Then there's color. You can change color, you can change red, you can change green. Is lit. RGB dot is lit. No, that's a property. I needn't. There. is true because it is. So if I go RGB dot color equals 0, 0, 0, everything goes off. So if I go is lit, it's false. That's great. What else do we have? Invert. RGB dot invert. Now, as that's a method, I do need to put in the brackets. Yep. As it was 0, it turns on as white. But if I change the color to, if I go RGB dot red, no, actually I'll invert it again, or I turn it off again, because then you can see better. Then I'll go RGB dot red equals 255. Red comes on. Now, if you look at a color wheel, red is opposite cyan. So if I invert, that ought to come on as cyan. Hurrah! It does. It works like anything. What else can this do? It can't blink. It can't blink. Well, it can blink, but it wouldn't be very good blinking. So have I done toggle? No, I can do RGB dot toggle. And that's the method, so I have to, yep, it's off, it's on. Now, what you can do is, if I grab another line, I can have the other RGB LED at the same time. So I need to call it something different. So it's RGB2, and it's different pin numbers, and common cathode equals false. So nothing's happened. So if I go RGB2 dot red equals 255, red's come on and nothing's happened to the other one. So you can have two going on at the same time, and the same program will cope with whether it's common cathode or common anode, as I will show you. Excuse me. So I don't know whether I need to explain any of this. No. I quite like that. I had to, in this set LED states, I've got the colours, as in, you know, in the format of a tuple of red, green, blue. And then, if self-active state, if that's true, that means it's a common cathode. So you just do your duty unsigned 16, blah, 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 like normally. But if it is a common anode, you have to take 255 and take away the colour, and it just works. Is there anything else of interest? No. Apart from being able to get and set all the properties. No. Ah, right, this toggle. I quite like this construct. You go, if colour equals off, then you say you want to set the colour to the previous colour. But if there wasn't a previous colour, as in if that equals none, it sets it to full on. And I think that's because of the OR statement. So it says self colour equals that, and if that is true, it doesn't bother to look at the OR 255, 255, 255. But if that is false, it sets it to that. which is quite handy. So I haven't exactly done what Paul wanted, and we won't look at the blink because the blink doesn't work. There, that's my video.